Indexes are very important for database operations. Generally speaking, indexes will improve the query performance, but indexes may slow down the performance when we change the database data. The performance may degrade when we change the database data because there is an overhead on maintaining the indexes. Here are the most common types of indexes. We will talk about each type briefly, but additional resources will be provided. Therefore, you can dive deep into a type if you are interested in it. Hash indexes are in memory and optimized to support queries. Here are the additional resources you can go to learn more about hash indexes. Memory-optimized non-clustered indexes are also in memory and optimized to support queries. Clustered indexes will sort the data and also determine how the data is stored in storage. Therefore, we can have only one clustered index on a table or on a view. Clustered indexes are implemented as a B-tree. The B-tree is not defined. It's implemented by a database vendor. Non-clustered indexes will not determine how the data is physically stored in storage. Therefore, we can have as many non-clustered indexes on a table or on a view as we need to. For example, if we have a customer table, we may create a clustered index on the customer ID, but we can also create non-clustered indexes on the customer's account numbers and the customer's phone numbers. Unique indexes will ensure there will be no duplicate value in the indexed columns. Column store indexes are in memory and optimized to support the data warehousing operations. Column store indexes can greatly improve the query performance. It will also increase the compression rate. A higher compression rate will improve the query performance and it will also save storage. Indexes with included columns are very useful. We can use this type of indexes to avoid the data type and size restrictions imposed by the database engine when we create indexes. If we can create an index on a computed column, we can greatly improve the performance because a computed column is usually calculated on the fly when the data is used. If we can index on a computed column, then the database engine will calculate the data and will prepare the data in advance. Therefore, the data is always ready for use. That's why the performance can be greatly improved. We can only index a computed column if the column is deterministic. This is how we can determine whether a computed column is deterministic or not. We will use the SQL system function column property. In this example, I used AdventureWorks. Filtered indexes are very useful if we just work with a portion or a part of a table, but not the complete table on a regular basis. Filtered indexes can improve the query performance, and also they can reduce the index maintenance overhead because less data needs to be maintained. Special indexes are great when we work with the geometry data type. XML indexes will straight and persist pieces of the XML structure. Therefore, the query of the XML structure can be greatly improved. Full-text indexes are token-based. We can use full-text indexes to do some very sophisticated word searches in character stream data type. We can go to this link and get additional details and information on all types of indexes we just talked about. This is the end of our discussion.